Welcome to ClickMyProject.com. Let me discuss about the project hybrid compression of hyperspectral images based on PCA with. Let me discuss about the abstract of the project. The reduction of hyperspectral image and multispectral image is an effective task in the domain of compression. The compression technique employed must be reversible in order to reuse the data further. Several factors make the constraints particularly stringent and the challenge exciting. First is the size of data. As a third dimension is added, the amount of data increases dramatically, making the compression necessary at different steps of the processing chain. Also, different properties are required at different stages of the processing chain with a variable trade-off. Second, the differences in spatial and spectral relation between values make the more traditional 3D compression algorithms obsolete. Here, the compression of hyperspectral image is proposed with the discrete orthogonal Stockwell transform under principal component analysis. The PCA algorithm is capable of reduction of dimensionality of the input hyperspectral images with the help of the calculation of eigenvalues and eigenvectors of the input hyperspectral matrix. The algorithm is based on a simple decomposition of the DOST matrix, conjugate symmetry for the DOST, and propose a variation of the parameters that exhibit symmetry akin to conjugate symmetry of the FFT of a real valued signal. Then these orthogonal features formed as an. Let me discuss about the flow diagram for our process. Initially, here the hyperspectral image is taken as the input image. Then the feature extraction will be performed. Here DOST feature extraction algorithm has been proposed. DOST means a discrete Stockwell transform. Stockwell transform of a hyperspectral image is defined as the Fourier transform of the product between hyperspectral image and Gaussian window function. And the ST decomposes a signal into temporal and frequency components. By the integral properties of the Gaussian function, the relation between Stockwell transform and Fourier transform of the hyperspectral image is proposed. Accumulation of the Stockwell decomposition over time yields the Fourier coefficients of the signal, highlighting the special feature of the Stockwell transform. The original function h of t can be recovered by calculating the inverse Fourier transform of the hyperspectral image using the equivalent frequency domain definition of the Stockwell transform, the discrete Stockwell transform, and the whole dataset consisting of a d-dimensional samples ignoring the class labels. And we obtain the residual image from the feature image which has been extracted from the DOST method, and compute the compression of the hyperspectral image using principal component analysis. The principal component analysis, here the eigenvectors and eigenvalues are proposed. Sort the eigenvectors by decreasing the eigenvalues and choose the eigenvectors with the largest eigenvalues to form a d-dimensional matrix. Next, this can be summarized with the help of dimensionality vector. And finally, we obtain the compressed image. A number of feature extraction methods have been proposed for pattern classification. And finally, the decision boundary feature extraction method has been proposed with the help of canonical analysis. And the covariance matrix which has been used for obtaining the compressed image. Then the decompression process will be performed by reversing the operation of PCA and obtain the decompressed image from which the feature extraction has been extracted in order to obtain the original hyperspectral image from the decompressed result using DOST algorithm. Finally, we estimate the performance analysis. for our accuracy, sensitivity and specificity. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right-click that file and run for executing this process. Select any one hyperspectral image from the dataset folder. Here I display the hyperspectral image in the figure window. Here I display every band of hyperspectral image. This is the pre-processed result of hyperspectral image of all bands. This is the feature values which I have extracted using DOST method, and this is the feature image which we have obtained using DOST method. This is the residual image which we have extracted from the feature image. After that, we are going to perform the compression process using principal component analysis, that is a dimensionality reduction method. Here we have obtained the compressed image using PCA algorithm. After that, we are going to perform the reversal operation of PCA in order to perform the decompression process. This is the reconstructed original residual image, and this is the reversal operation of DOST method which we have obtained reconstructed original image. And we are performing the performance graph for various method versus our proposed method, and this is the performance graph of accuracy between various and also our proposed method, and this is the accuracy graph between various method and also a proposed method for different classes. Here we perform the effective compression algorithm using DOST and also PCA. Thank you.